Okay, welcome back. We're still talking about the scientific revolution. This is essential question 6.2. And the last essential question, we talked about some of the main people in the scientific revolution and how the scientific revolution changed people's ideas about the universe. Like we talked about Galileo, Copernicus, Kepler, Newton, Descartes, all those guys. Well, today we're trying to find out how did the new science, and by new science I mean, I'll explain on another slide, but this is something totally new. This new form of science. So how did the new science change society and education? All right. Pause if you need to. Let's jump right into this. Okay. All right. New ideas in medicine. So let's talk about, once again, always, if you're going to talk about change, we have to talk about what people did before, right? So remember just how Ptolemy around 100 CE was looking up at the stars and the sky and saying, oh, the earth must be still and everything rotates around the earth. Well, there was this guy named Galen, all right? He lived about 100 CE, around the same time as Ptolemy. And what this guy did was he studied animals to come up with ideas about human anatomy. All right, now, that's a great thing, right? Cutting open, animals, dissecting animals, just like you guys do if you take a basic anatomy class. When I was in anatomy, I think we dissected frogs. My nephew teaches anatomy, and they dissect cow eyeballs, and they dissect pigs. But by dissecting animals, you can learn kind of how things work. You can see, organs of animals and, things like that. But it's not near as good as dissecting humans. Now, question, think about this. Why around this time period might you not dissect a human? Ah, you're right. I felt like Mickey Mouse Clubhouse. Do you see Pete? And he waits a little bit. You're right. Well, if you said that dissecting human beings might have been against the law, maybe against the church, maybe creepy, you'd have been right. Okay, yeah, so people didn't go around back in the day dissecting humans until the scientific revolution. And even then, it wasn't exactly looked upon as something that should be done. All right, so you've got two guys in the scientific revolution. One of his names is Andreas Vesalius, and the other man's name is William Harvey. And what these guys did was they started dissecting human bodies, obviously after they were dead. But like I said, human bodies were supposed to be, kind of like sacred things. You took care of them when people died. You buried them cautiously. One of the things you did not do is take their naked bodies and start cutting them apart and going, look at that. All right. And that's exactly what these guys are going to start doing. All right. So Vesalius, the first guy, was the first person to accurately describe the main organs of the body. So he looked inside the body and said, okay, well, there's the heart, there's the liver, there's the stomach, all of these things. And as you can see from these drawings right here, these are some of Vesalius's drawings. You can see on the right the muscles of the body, and you can see on the left the skeletal figure of the body. Do you guys ever see the exhibit that comes through LA sometime? If you never have, it's fascinating. It's called Body Works. And Body Works, Body World, something like that. I saw it at my last school, and it's basically you go look at people, and they are pretty much, their skin is taken off, and their body's been plasticized, and it's really interesting. Anyway, kind of creepy too. So yeah, but think about this. They're dissecting the human body, and what people are going to start learning is that much like the universe, the human body works like a machine. So, if you can figure out how the human body works, you might be able to fix the human body. Well, William Harvey is going to prove that it's the heart that actually circulates blood throughout the entire body, not the liver, because Galen, once again, looking back on the old people, and how they used to do things, Galen thought it was the liver that pumped blood, but it was actually the heart. And another thing that Harvey proved was the heart pumps blood throughout the entire body. Okay? So once again, all of these discoveries are kind of demystifying the universe and the human body and making things understandable. Because like I said, if you understand how the universe works, then you could make the universe work for you, if that makes sense. Same way with the human body. If you can understand how the human body works, then you might be able to understand cures for diseases, right? So, Blaise Pascal. We're going to talk about him in a little bit later with a different kind of philosophy of science, but one of the things that he does practically is he did a lot of experiments with liquids under pressure. All right, guys, I don't know if you know this, but if you're in the medical academy, you probably know this, but the human body is under pressure. All right, your blood, it's called blood pressure, right? And the pressure pumps blood throughout the entire system. Well, by doing so, he developed some of the earliest syringes, all right, that Europeans had. So all of these things, like I said, are demystifying the human body, and it's showing that the human body can be figured out and understood. But once again, it's also showing that maybe the human body is not so special, right? Because now people are dissecting the human body like animals. Once again, it's one of those things that think about, like the Catholic Church and the kind of perception they're trying to put out that humans are special and, all of these things. But now science is starting to say that humans can be understood, right? Maybe plagues aren't because God is angry. Maybe plagues happen because of some natural phenomenon that we can understand. So like I said, think about the implications of that. All right? Pause if you need to. We're moving on. All right, new institutions of learning. Okay? So, during this time period, let's talk about like the status of what education means. All right? Now, universities have been around for a long time. Okay, but here's the thing about modern universities at this time period. They still focused on old ideas like scholasticism. You remember scholasticism, like learning the Bible and the biblical arguments and things like that, right? Well, if you went to a university, that's still the kinds of things that you're learning. And another big thing is scholars at the time period are still saying, Aristotle had the best idea about this, and Socrates, and all. They're still basically harping on the same old ideas of the Renaissance. They still hold the old Greeks and Romans as the standard of what we should learn. Here's the problem, though, all right? A lot of people are like, hey, why don't we learn some new ideas, okay? Maybe the Greeks and Romans didn't have it all figured out. So a lot of nations began to develop individual institutions sharing the new science. And I don't know why it says scient. I am sorry, guys. It's a misspelling. It should say science. Don't treat it like that one SAQ that said one reformat instead of saying one reform that the Protestants demanded, right? So, guys, so what I'm saying is basically because the universities were still teaching the old ideas, a lot of people said, well, what if we make new institutions that are not the universities to study the new science? Because they're not studying the new science in the universities, which I know, doesn't that sound kind of weird? Like, wouldn't you study the most modern ideas at universities? Well, no. One thing you've seen right now is Europeans are very reluctant to change, right? Okay, so what they started to do was create what are called academies of learning. And I'm just going to run off a few quick examples just to show you that pretty much every major state or nation had their own little academy of learning, okay? So what they did was they published, they debated, they experimented, they shared information. You might have someone like Vesalius dissecting a human body at one of these institutes, and you might have a crowd of people watching him dissect this body and saying, this right here's the heart, it pumps blood, this right here is the stomach, it digests food. And it was, one of the places they could go and do the new science, and they would sit there and debate about it. They would argue back and forth, and they would come up with new ideas and share information. All right? So this is where we're going to start thinking that the idea that, look, science cannot only be beneficial to the human body and the universe, science can actually help the government. It can grow the economy. And some nations are going to latch on to this idea that science is good. And they're going to allow ideas to spread freely. And in those countries, in those nations, basically those are going to become the most powerful nations in Europe. For instance, Great Britain. They're going to become very powerful because ideas are spread freely, and they're not such sticklers like the French or the Spanish, where the Roman Catholic Church is trying to shut down all these ideas, right? Okay? All right, so in Florence, Italy, one of the earliest ones was called the Academy of Experiments in 1657. All right, so the same place, Italy, where the Renaissance is born, they're going to have a very, big shock, not really, scientific ideas come out of Florence. All right? The Royal Society of London is going to be created in 1660. France is going to have their own Academy of Science in 1666. And like I said, all of these academies throughout all these nations are going to start focusing on the new science. So the scientific revolution is going to spread through these academies of learning, not through the old universities, because they're still focused on old ideas. All right? There's one more thing on the slide, guys, but don't write it because it's redundant. I already said it in another bullet. Okay? All right. So those are what I'm talking about, the new institutions of learning, these royal academies. All right? Pause if you need to. We're moving on. All right, women in the scientific revolution. Well, almost every chapter, if we haven't already, I can't remember, but almost every chapter from now on, we're going to pretty much talk about, well, what's going on with women in every part of the every period of history. So now, I don't know why I'm laughing, but that one is really tiny. I don't know why that one is so tiny. Look at that little guy, that cute little guy. Anyway, I'm sorry, it's weird. Okay, education. All right, so now at this point, and not for a long time, women are not going to be admitted to any academy or any university. You see, it's kind of thought at this point that that's not really the place for women. Europeans for a very long time are still going to have this very traditional idea that, women are the mothers of children. They take care of the household and the finances of the household and things like that. That is what women do. And it's men's job to do other things like engage in science and go to the university or, certain jobs, right? So women are not admitted to the academies or universities or anything like that, but that does not mean that there aren't some exceptional women, okay? One woman was Margaret Cavendish, all right? Margaret Cavendish was an English woman. She was a noble, all right? So she was, very high up on the social hierarchy of England, and she's actually... she's more of a philosopher than a scientist herself, but she wrote a very famous work called Observations Upon Experimental Philosophy. And while that sounds like a really boring title, it's actually kind of funny what she did. She's basically going to criticize English scientists for not solving practical problems. So let me tell you what I mean. So basically, there's all this new technology like syringes, and there's microscopes that are going to be invented, and telescopes, and all these new tools. And what English scientists are doing is basically playing with these tools like, ooh, look what I can see in this. Ooh, look, I've got a telescope. And she's kind of argues that, well, so what? All right, this is my observation on your experiments. They're useless. They're not practical. They don't give us any knowledge. You're just basically using these tools as a toy. So she really kind of goes after the scientist of England, saying that they're not really doing anything. They're just using the instruments for, fun, kind of. Okay? All right, now, Maria Winkelmann is a German. All right, now, guys, obviously Germany doesn't exist, but she lives in the German states in the Holy Roman Empire. And here's the deal. Her husband is an astronomer, all right? And what they do is they both make calendars for the Berlin Academy. So remember, the Berlin Academy is just another scientific institution, right? And that's kind of how they make their living. So her husband's an astronomer, but her husband teaches Maria Winkelmann how to be an astronomer and how to make mathematical calculations and all these things. And what actually happens is her husband dies, and even though she did a lot of the work and made calendars herself, basically she says, hey, can I take my husband's place in the academy? And the Academy of Berlin says, no, you can't because you're a woman. All right. But anyway, it just goes to show that she was doing the same job as her husband. Now, Amélie du Châtelet was a French scientist, and what she is actually known for is she translates Isaac Newton's Principia Mathematica that we talked about in Essential Question 6.1 into French. Now, you may think, well, whoop-de-doo, she translated a book. No, guys, she translated a complex mathematical book, which there's no way she could have translated that without knowing the math herself. And it's because of Amélie du Châtelet that all of these mathematical ideas are now going to go into France, because Isaac Newton is not French. All right? So the French mathematicians owe a lot to her because she translated the book. All right. So what you see here there are examples of women that are involved in the scientific revolution, although not officially because they're not allowed into the universities or the academies. All right. So pause if you need to. We're moving on. All right, now science and religion. Now this is something that, when we were talking about Galileo, that we were all kind of struggling with understanding a little bit, so maybe I can kind of clarify some ideas. All right? So there's a lot of questions that are now starting to emerge, and I'll be honest with you, some people question these same things even today in our modern society, okay? But as all these new ideas come out, obviously educated people start to think about things like this. What do you do when science and religion don't match up? I mean, think about it. What do you do when the Roman Catholic Church says, if you read the book of Joshua, it talks about how the earth, or the sun stood still and the moon stood still? All right? But modern science is saying that the sun's at the center of the earth, and actually the earth moves around the sun. So what do you do? Who do you believe? Here's another question that people are struggling with during this time period. Who decides conflicts between religion and science? Who decides? All right, who's the right answer? Who's the final word? Is it the Pope or is it the modern scientists? Okay? All right, number 3. Do the Bible and science actually go together? Can they go together? Should they be completely separate? So these are all, like I said, things that people in the 1600s are struggling with, but I'll be honest with you guys, they are something that people struggle with today. All right, these very same questions. So let's give a couple examples. Number 1, Galileo. So if you were in class, we actually looked at Galileo. Here's an 1800s painting of Galileo defending himself in front of the Catholic Church. But if you were in class, we already looked at the primary sources. Did Galileo really commit heresy? And if you look at the sources, he really didn't commit heresy. But nevertheless, the Catholic Church condemned him as a heretic for supporting Copernicus's idea that the sun was at the center of what we knew as the universe. Now, obviously, guys, today we know that the sun is not even at the center of the universe. It's at the center of our solar system, which is not even anywhere near the center of our galaxy, which is not anywhere near the center of the universe. So anyway, long story. Okay? And then he lived under house arrest until his death. So at the point of Galileo, people were still very much afraid of publishing ideas. I mean, Galileo was given the option, look, you can recant your ideas and say that they're not true and that you were lying, or we'll burn you at the stake. And Galileo very wisely said, oh, no, I recant. No, absolutely, I don't want to burn at the stake. Okay? So, pause if you need to. We're going to move on to our last slide. All right, now, there are a few people that have some new ideas, and one of these guys is Blaise Pascal, the very same guy that I told you that that invented syringes and things like that, right? So, Blaise Pascal, he wrote this book called Pensées, all right? And in Pensées, he argued that faith and science should really be viewed in separate spheres. So science over there, faith over there, and you really shouldn't put them together, all right? Okay, and that is very much a belief that some people to this day very still hold strong too, that you should have your faith over here and your science over here, and you shouldn't mix them. All right, but Blaise Pascal did say that both faith and science are important. It's not that one is better than the other. They both have different purposes in life. And like I said, this is a very common belief today, that you should separate faith and science, just like you should separate government and religion, right? It's called separation of church and state, okay? Basically like what we're learning that some people are arguing right now in the 1600s, the government shouldn't care about what religion you are, and the religion should not be in control of government, right? They're struggling with that right now in the 1600s. So he said, look, faith and science, they should be separate. You shouldn't put them together. All right, now, Francis Bacon, the guy that we talked about in 6.1, all right, the English philosopher argued that studying the Bible and nature together kind of help you understand both. All right, so if you study science, then it kind of helps you understand the Bible. If you study the Bible, it helps you understand science. And there are some people to this day, guys, that still kind of have this belief, science and religion go together. All right? Now, the big thing that Francis Bacon's also going to say is look, and this is kind of a shot at the Catholic Church. Look, God placed humans on this earth if you believe in Christianity. And God gave humans brains to understand complicated things. New ideas should not be feared because God created humans to be able to come up with new ideas, all right? And that's going to be kind of Francis Bacon's idea that, like I said, is going to be kind of an argument against the censorship of the Catholic Church, all right? So hopefully you guys have seen in these quick short notes here that society's changing. The way we look at education's changing. The way we look at religion is changing, all right? So anyway, that's in the notes, guys. I'll see you tomorrow. Have a good night.